Hello everyone, this is Rashida. Welcome to my channel. My today's video is going to be on TF-IDF Vectorizer. This is a continuation of my last video on count vectorizer. This is also another method of converting text to numeric data. So first we will learn the theory, the formula behind it, and then we will implement TF-IDF Vectorizer using Python scikit-learn library. So what is TF-IDF Vectorizer? So it gives a score for each word, where it evaluates the word's usefulness in the sentence. In other words, it calculates a score that indicates the relevance of the word in the document. So the sentence, you can call it document as well, you will see it later. Overall, TF-IDF measures the usage of a word compared to all the words used in the entire document. So let's break it down. TF and IDF. So there are two parts to it, TF and IDF. So first, in this page, you see the formula for TF. TF stands for term frequency. It can be calculated using either of these two formulas. The first one is very simple, simply the number of occurrence of a word in a document, or the number of occurrence in a document divided by number of words in a document. That means the number of total words. Let's see how it works. So here I'm going to calculate TF for this sentence. My name is Lily. If I use the first one, the number of occurrence of word in a document, in that case each one is 1. The TF for each one is 1. My is 1 because it occurred only once in this document. Name is also 1. It occurred only once, same as Lily and is. Right? Now let's how TF comes out to be using the second formula. My number of occurrence of the word, that is 1. My occurred only 1, right? Divided by the total number of words in the document. The total number is 4. 1, 2, 3, 4. So 1 over 4, 0.25. For the name, the same thing. It appeared only 1 divided by the total number 4, 0.25. Same for the is, same for Lily, all 0.25. Let's see how IDF can be calculated. IDF stands for inverse document frequency. So this one is a little bit more complicated than calculating TF. There are two types of formula. One is IDF can be 1 plus ln e based log n divided by df. Here n is the number of documents available and df means number of documents where the term appears. We will work on an example after this, so it will be much clearer. So this formula, you can exclude the 1 as well. Okay, if you exclude the 1, it becomes just this term, ln n divided by dft. But as per scikit-learn library's documentation, in the scikit-learn library, they use this formula. By default, usually they calculate ln 1 plus n divided by 1 plus df, then plus 1. This is the default. Or if you use smooth IDF equals to true as the parameter, you don't need to use this 1. In that case, ln 1 over df plus 1. Let's work on an example, and I'm going to use this formula, this one. Later on, I will show you a complete example using this formula in an Excel sheet, but for now, let's see how this one works. So this is the formula, and this is our 3 documents. My name is Lily. Lily is my mom's favorite flower, and my mom loves flowers. So let's calculate the IDF values. First, I take the word my. My equals to ln, then n. N is the total number of documents. That means we have 3 documents here. It's 3. And then DFT, that means how many documents has the word we are looking at right now. So we are looking at my. And we have my in all 3 documents. My name, Lily is my mom. So DF also is 3. So ln 3 over 3, which is 0. Next, I will take name, this word name. So again, The total number of documents, that means n, is 3, divided by the df, that means how many documents carries this word name. It's only one, the first one, right? Name. There is no name in these two documents, second one or third one. So ln 3 divided by 1 equals to 1.1. Using the same process, you can calculate the IDF for each word. Now let's use this one. Okay, this one, what scikit-learn library usually use. Here I have the Excel sheet for you, and you can see that TF, I'm going to use this formula because that's what scikit-learn library use. Just simple number of occurrence of a word in a document. In IDF, this formula, ln 1 plus n divided by 1 plus df plus 1. And here we have our 3 documents. My name is Lily, and the other 2. And see, we have all the words listed here. First, I take my. So for my TF term frequency, in document 1, it appeared only once, so 1. Document 2, my appeared once as well, again 1. And document 3 also, my appeared once, so again 1. Now IDF. Now if I put my cursor here, here, you can see the values here. So ln 1 plus n. N is 3, that means the total number of documents we have is 3. And then divided by 1 plus df. 1 plus df, that means how many times or how many documents have this word. So all 3 documents have my name. Lily is my mom. 1 plus 3 and then plus 1 plus 1. So if you do that, you get 1. And for document 2 also it will be the same. N is always 3, right? Because we have 3 documents for all the words. The bottom part only the df changes. But for df also we have 3, mine. All 3 documents have mine. So it's going to be for document 2 also IDF will be 1, and document 3 also it will be the same. And TF-IDF is TF times IDF. So 1 times 1, it's 1. Let's look at another one, the word name. For document 1, it's 1, the term frequency, because it occurred only once in the document 1. In document 2, it's 0, there is no name. Document 3, it's 0 again because there is no name in document 3. And IDF. So using this formula, again, the top part is going to be the same, 1 plus 3, because we have 3 documents. And the bottom part is 1 plus df. How many documents have this word name? Only 1, right? So 1 plus df1, 1. And then finally plus 1. So we get 1.69. Then document 2, if you look at it, ln 1 plus 3, as usual, top part doesn't change. And in the bottom, 1 plus df. So df means how many documents carries this word name. That's actually 1, but somehow, okay, I made a mistake here. It's not 0, it has to be 1. And then plus 1. So it's the same for both of them. And this one also, the IDF value for all 3 documents will be the same actually. 1. Okay, it's the same. But anyway, it doesn't change our result. If you look at it, TF-IDF, TF times IDF. So the first one, 1.69, second one is 0 because TF is 0. For the third one, third document, the TF times IDF is 0 because TF is 0. In the same way, you can calculate the TF-IDF for all of them. Now, we need to normalize the TF-IDF. And how do you do that? Let's have a look. So I take this whole table and I put it here. And then I deleted the TF and IDF part and I kept only the TF-IDF. Now I want to normalize this TF-IDF values so that I get the value from 0 to 1. And how we do that? So you can see I have the sum of squared. So how we did it? Sum of squared. So I took this for this document 1, all these values, I squared them and then summed them. So that was sum of squared. I did the same for second document and same for third document. Okay, so I have this SS values here. And then here you see what I did. So this value came from this one divided by square root of this one. That's how I get this normalized TF-IDF value for mine for document 1. And for second one, I again take this value and then divide it by square root of this one. If I look at this one here, so what I did, I took this value, then divided by square root of this one. In that way, I got the normalized TF-IDF values for all of them. Let's see how we can do it in sklearn library. Here I have it, the text. I have the same 3 documents. Then I import TF-IDF Vectorizer from sklearn.featureextraction.txt. Then in this vectorizer, I call this TF-IDF Vectorizer method. Simply vectorizer.fit transform this text. If I convert this to an array, this is what I get. All the TF-IDF values, I want to convert them to the pandas data frame so that I can see it clearly for each word. So import pandas as PD and then pd.dataframe. The data is x.toArray, this array, and then columns, you can get this vectorizer dot get feature names. That will give you the each word. For each word, these are the TF-IDF vectorized value. If you compare these numbers, these are pretty close to the numbers we calculated in the Excel sheet. Look at this mine, document 1, 0.37. What we have here, 0.356. It's pretty close. I can take it. If I check for mom, document 1, look at 0.392. And here you have 0.376. So almost 0.38. So they're pretty close, pretty closely aligned with all of these numbers. If you want, you can improve this a little bit. I passed stop words equals to English. When you pass stop words equals to English, it uses a list of words that may not be that useful for your machine learning model. Just think that we have only 3 documents, so we have only these few words. But what if we have thousands of documents? In that case, we may have thousands of words. And in that case, we will have thousands of columns. That is going to be really big. So if you want to take off some of the stop words, it will save you lots of computation time. So just have a look. Once I used the stop words English, it just took off this is, my, and name. Okay? Because name is also one stop words that we have as default in TF-IDF Vectorizer method. Now, if you do not want this default method, if you want, you can have your own stop words list here. Maybe is, my. Now, if I want to take out maybe Lily, I don't need somebody's name maybe. And then what if I want to take name as well? Or maybe let's keep the name this time. You can see this time we have the word name, but we do not have the word Lily here. I put the link of the TF-IDF Vectorizer's documentation in the description box below. Please feel free to check and use some other parameters and experiment with it. In my next video, I will show you how we can use Count Vectorizer and TF-IDF Vectorizer both to do a complete sentiment analysis. So please stay tuned. If you like this video, please like, comment, share, and subscribe. Thank you so much for watching.